These are the Lesson 9.4 notes on rational expressions. Today we're going to simplify, multiply, and divide rational expressions. We'll also state restrictions on the variable and explain what that means. We're going to look at this first example, 3x plus 12 over x squared plus 5x plus 4. To simplify this expression, the first thing we're going to do is factor it. And you may recall one of the first rules in factoring is if you can take out a common factor for each term, do that. In the numerator, you can do that. You can take a 3 out. And in parentheses, if you divide 3x by 3, you get x. And if you divide a positive 12 by 3, you get a positive 4. In the denominator, we have a trinomial. You may recall when you're working with trinomials, what we're going to do is we're going to look for two factors. The first term will be x in each of these factors. And to find the second term, we're going to look for two other numbers whose product is 4 and whose sum is 5. If you want to do that over here and write down numbers whose product is 4 and whose sum is 5, you can attempt to do that over here. Numbers whose product is 4, there aren't a lot of choices. Obviously, you can do 1 times 4, you can do 2 times 2, and obviously the choice you want is the 1 times 4, because 1 plus 4 equals 5. So we'll do an x plus 1 and an x plus 4 here. Once you've come up with common factors, we'll cancel common factors. That would be the x plus 4 and the x plus 4. And this simplifies into 3 in the numerator over x plus 1 in the denominator. Now we're also going to state restrictions on the variable, what we don't want x to be equal to avoid zeros in the denominator. In this problem, obviously we don't want x to be equal to negative 1, because if x was equal to negative 1, then we would get 0 in the denominator. In addition, at some point we also had this x plus 4 in the denominator. That means that we also don't want x to equal negative 4, because if it equaled negative 4 at the beginning of this problem, we'd be dividing by 0 as well. So this is what your solution should look like. 3 over x plus 1 is the simplified expression. These are the restrictions. X can't equal negative 1 and x can't equal negative 4. What I'd like you to do in just a moment is pause the video, attempt to simplify this expression, and see if you can come up with the restrictions for this one as well. So here we can take a common factor of 5 out of the numerator. We have x minus 2 in parentheses. In the denominator, we have a difference of squares. This would factor into x plus 2 times x minus 2. To simplify this expression, we will cancel out the common factors of x minus 2. What we're left with is 5 over x plus 2. And our restrictions here is that we definitely don't want x to equal negative 2, because that would give us a 0 in this denominator. But also originally we also at one point had an x minus 2 in the denominator, so we wouldn't want x to equal 2 either. These are your restrictions for this problem, and your simplified expression is 5 over x plus 2. Now let's take a look at what happens when we multiply rational expressions. When we multiply rational expressions, we're going to factor if necessary, reduce numerical fractions, think of what can we divide out of each number, cancel common algebra factors, and state restrictions on the variable. There's nothing to factor at this point. We do have numerical fractions that can be reduced. 3 over 4 cannot be reduced, nor can 8 over 15. But we do have an 8 and a 4 in a numerator and denominator, which means that if we divide both of these numbers by 4, this number here would become a 2, and this number here would become a 1, essentially canceling it out. Likewise, you could divide the top and bottom by 3. That would cancel this one out more or less and leave you 5 here. Now we can also cancel common algebra factors. That would be your variables here. Notice that we have a y on the top, there's a y to the 5th on bottom, so you could cancel out a y from each side and you'd be left with 4 down here. And likewise, you could cancel out x squared. That would cancel it out here, and the numerator you'd just be left with a single x. So what do we have here? Well, we had a 2 and there's an x, and in the denominator there's a 5 and we had a y to the 4th. Restrictions? Because there was an x in the problem, if we kind of erase what we had here originally, there was an x in the bottom. We don't want x to equal 0. That would make this entire denominator equal to 0. So we don't want x to equal 0. And likewise, we don't want y to equal 0 either. So your solution is 2x divided by 5y to the 4th power, comma, x can't equal 0 and y can't equal 0. What I'd like you to do is I'd like you to pause the video, do some factoring of all of the numerators and denominators in these fractions, cancel, simplify, and state restrictions. We'll see what you come up with in just a moment. So we factored all of the numerators and denominators. We have a trinomial in the first fraction in the numerator, which factors into x plus 2 times x plus 3. The denominator, you can take out a 4, and you're left with x plus 1 in parentheses. The second numerator is a difference of squares. It's x plus 1 times x minus 1. And we have this trinomial in the bottom right corner, which factors into x plus 2 times x minus 1. There are no numbers that we can divide out here, but we can cancel common algebra factors. As long as it appears in a numerator and a denominator, we can cancel it out. Obviously, we have x minus 1s on the far right side. These will go away. I see an x plus 1 here and an x plus 1 there. These will cancel out and go away. I see an x plus 2 here and an x plus 2 here. These will cancel out and go away. And all we're left with is x plus 3 over 4. What can't x equal? Well, you can see in the first fraction, the denominator at one point did have an x plus 1, so x can't equal negative 1. We also had a denominator of x plus 2 here, so x can't equal negative 2. And likewise, when you see x minus 1, it means that x can't equal 1. Here is your solution, x plus 3 over 4, and your restrictions, x can't equal negative 1, negative 2, or positive 1. The last thing we'll look at today is dividing rational expressions. Same idea as before. We're going to be working with factoring. We're going to be canceling out common factors in the numerator and denominator. The only difference is when you do a division problem, we multiply by the reciprocal. In other words, we're flipping the second fraction. Otherwise, we'll follow the same steps as before. So here we have 4x plus 12. We can obviously factor out a 4, and you're left with x plus 3. Denominator, 2x plus 2, you can take out a 2, and you're left with x plus 1. Now I'm going to change this divide sign to a multiply sign, but I'm also going to flip-flop these two fractions around. So what's going to happen is the 5x plus 5 goes to the top, and I can take a 5 out of both terms. We're left with x plus 1 in parentheses. With the x squared minus 9, that's a difference of squares. That's going to turn to x plus 3 times x minus 3. Now, just like before, we can cancel out various things. You'll notice we have a 4 over 2 right here. You can divide top and bottom by 2. This will cancel, and we're left with a 2 here. X plus 3 is in the top and bottom. Those will cancel. X plus 1 is in the top and bottom. These will cancel. What are we left with? Well, a 2 and a 5 in the numerator that are being multiplied. That's equal to 10. Denominator, lots of things cancel, just left with x minus 3. Now, it doesn't say anything about stating the restrictions here. If it did, you wouldn't want x to equal negative 1, negative 3, or 3. Some problems tonight, it may say to state the restrictions. Other problems, it might not. If it doesn't state it, you don't have to do that. If you were stating them, let's put in parentheses, then you would certainly say that x couldn't equal negative 1, negative 3, or positive 3. One last time, I'd like you to pause the video, see if you can solve this problem. Don't forget to flip the second fraction and multiply. We'll take a look at your answers in just a moment. For our last problem, we're going to factor 6x squared minus x minus 1. Now, I've included the steps directly above the problem in this cloud I'm drawing right here. You may recall that we can kind of do this little x box right here, looking for two numbers whose product is negative 6 and whose sum is negative 1. That would be negative 3 and 2. So you replace the middle terms with negative 3x and 2x. You do your factoring of each of the first two terms, and then you take out a 2x minus 1 from each term, and you have 3x plus 1. So that's where this comes from. I'm going to flip 2x squared minus x. It's going to go to the top. I can take an x out, and I have 2x minus 1 in parentheses. And with x cubed plus 4x squared, I can take an x squared out of both terms, and I'm left with x plus 4. Now's the fun part where we start canceling things. I have 2x minus 1 in the numerator denominator, so we can cancel those out. I can take out, I have an x cubed here, I have an x squared here, so I can take an x squared out of the top and bottom. This will turn this into an x. Other than that, it looks like I've got a 4, an x, and an x, and I've got a 3x plus 1 and an x plus 4 here. So my answer is 4x times x, which is 4x squared, and my denominator is 3x plus 1 times x plus 4. Again, it doesn't say to state the restrictions. If you did state the restrictions, you would not want x to equal negative 1/3. That would cause my 3x plus 1 to equal 0. I wouldn't want x to equal 1/2 because that would cause 2x minus 1 to equal 0. I don't want x to equal 0 because 0 squared is 0. And I also don't want x to equal negative 4. These would be the restrictions, and that's how you simplify, multiply, and divide rational expressions.